Hello all, welcome to Excel Academy. So today we are having one more video on control system. So this video is based upon terminologies used in signal flow graph. So according to this particular video, so we are having various terminologies that we use in signal flow graph, and this video I say is very important. Why important? I say it's not important. I'm so sorry. I say it is super important. It is because you're supposed to, what I can say, practice all this. So if you know all this, you can analyze the particular diagram, as well as you can, what I can say, identify these terminologies that's used in signal flow graph, which is present in the diagram, so that if you understand that only you can solve. That is why we are telling what are the parts that is present in the signal flow graph, so that we are going to tell it to you, and that particular thing you are supposed to analyze without fail. So you have to analyze in the diagram, and if you try to analyze in the diagram only, you can try to solve the problem. That is why this is super important, and please to understand. Right now, let me come to what I can say, the very first one. My very first one is what is called as my source node. You have three nodes, and the types of nodes, you have three nodes. One is source. I'm going to write all the three together. One is source, one is sink, and one is what I can say the chain node, right? What is my source node? Just a minute. Wait a minute, students. Yes. What is a chain node? So I'm sorry, source node. So source node is what? It is a node which is consisting of only outgoing branches. What? It is a node that is consisting of only outgoing branches. So that is why, that is what I can tell it as my source node, right? I repeat it again. The node which is consisting of only outgoing branches. So it is what is called as my source node. For this theory, I'm going to share the pics in the YouTube. Please do watch it without fail, right? Yes. And what is my source node? Let us consider this diagram, and by this diagram only we are going to understand the terminologies, few of the terminologies. For the later ones, we are going to draw the separate diagrams, right? Yes. And here my x naught is my source node. How I can say that my x naught is my source node? I already told you that. So this is what is here. These are all my outgoing nodes, right? These are all my outgoing nodes, and these are all my incoming. So therefore for my x naught, all the nodes are, so what I can say, for my x naught, all the nodes are what I can say outgoing. That is the branches. See, these branches are outgoing branches. It is not entering x naught. It is leaving x naught. See, this is leaving x naught. These branches, whatever is present, it is leaving x naught. So I can tell that it is my x naught is my source node. Okay, source node got clear. What is my sink node? My sink node is the what I can say, the node which is consisting of incoming branches. So incoming branches, that is xy, right? For xy, you can see that all these branches are entering xy. So this t 4 5 and t3 4 t2 3 t1 2 and 1 all are entering xy. Okay, so that is why you can tell it as xy is a sink node. That is the node which is consisting of incoming branches. So that is what I call it as, what I can say, the sink node. What is a chain node? A chain node is the one which is consisting of both incoming and outgoing nodes, right? A chain node is the one which is having both incoming as well as, what I can say, both incoming as well as my outgoing nodes. That is what I call it as, what I can say, the chain node, right? You understood what is source, sink and chain. What is my source node? A node which is consisting of only outgoing branches. Sink node, a node which is consisting of only incoming branches. And chain node, that is a node which is consisting of, what I can say, the incoming as well as outgoing branches. So that is what is I call it as, what I can say, my chain node. Okay, so I guess you understood this clearly. For your x naught, this is leaving. What? For your x naught, this is leaving. It is not entering x naught. See, this is entering for xy. This symbol, it is entering for xy. For xy, these branch gains are, what I can say, branch what I can say, the branch in these branches are entering xy, but for x0 these branches are leaving for x1. These branches are what? So these branches are leaving for x0. So that is why I say that my x0 is my source node and xy is my sink node, right? Yes, because they are all having incoming branches, right? Yes. And now here coming on to the other one. So what is the other one? The other one is that it is a forward path. What is the forward path? Just let me write that. Okay. What is the forward path? The forward path is that, so it states that a path from the input to the output node. That is, the path from the input to the output node is called as forward path. And my very first path is x0, x1, x2. What I can say, x0, x1, x2, x3, x4 and xy, right? This is x0, just a minute, x0, x1, x2, x3, x4 and xy. The straight line path, right? x0, x1, x2, x3, x4 and x5 is the path. And my next one is what? So my second one is, my second path is what? That is x0, x1, x3, x4 and x5. That is this x0, this x1, this is showcasing. See, your arrow mark is showcasing here. Please to analyze x1. What I can say, my x3. So you should not go to x2. Where is x3? It is x3. x3, x4, x5. That is what is my path, right? How is that? See, x0, x1. This is x3, x3. What I can say, the x3, the x4 and x5, right? Yes, just a minute. I have forgot one arrow mark here. Okay. So this is x0, x1, this line comes here, and this is x1, and here it goes here, and it is once again x3, and here it comes back, and it is x4 and x5, right? Yes. And just a minute, students, there is a small glitch. I'll clear it over here. So wait for a second. I'm so sorry. So here you have to make a joint over here, right? Here this is joint, and this line joins over here, and this line joins over here. I did not see that. Okay, yes. So sorry for the distraction that has been happening over here. I'm really sorry. Fine. Yes. Okay. So yes, okay. These two are joining here, so that is why it is x0, x1, x3, x4 and x5. And my next one is that it is x0, x1, x3, xy. x0, x1, your x3, where is your x3? Your x3, your x3, this and xy, right? Yes. And then my last one is x0, x1, x2, x3, xy. x0, x1, x2, x0, x1, x2, x3 and xy, right? Yes. So what I'm supposed to do is I'm going to write all these things without fail. So just a minute, give me some time. Okay. So this is what is my straight line, that is your x0. I'll just write it and showcase to you students in the, what I can say, the YouTube, and I'll just showcase it. I'll just share the picture of that. Okay. Yes. And now you understood what are the paths. One is the straight path. The second one is this x0, x1. Just a minute. I'm so sorry. Yeah. Okay. This x0, x1. Just a minute. Yeah. This x0, x1, x3. What I can say, x4, xy. And next one is x0, x1, x2, x3, and what I can say directly x3, and what I can say directly my xy, right? Which one? x0, x1, just a minute, x0, x1, x2, x3, and directly my xy, and once again it is my x0, x1, x3 and xy, right? Okay, so I'll just write it and showcase it to you so that you'll be more clear. So that is why I'm just a minute. I'll just take this. So sorry. Okay. So I couldn't write it over here. So there is some distraction. So let me try to write it here. Wait a second. So this is my very first part. That is what I can say my, just a minute. I'll just try to write it. 1, 2, 3, 4 and 5. And this is yeah, I could write it. I'm so sorry for the students, yes, because I thought I could write it on a sheet of paper and I would share it to you on YouTube, but yes, let me write it because I want you to understand things in a clear manner. Let us write x2. So it is what I can say my x3. This is t34 and t45, right? So this is what is my very first path, students. Yes, this is my first path number 1. My forward path number 1. And if I consider my forward path number 2, it is my which one? It is my x0, x1, x3, x4, x5. So x0, so x0, this is 1, your x1, your x3. So how come your x3 from x1? You have what I can say this particular, right? Yes, like this, right? Yes, x3, and here it is what I can say the this part, that is x3, and here it is my what I can say after x3 you have one t34, right? And this is x4, and this is what I can say my xy, right? This is x0, x1, and here it is x3, x1, here it is x3, here it is x3, what I can say the t34, x4, t45, and xy, right? Yes. So this is what is my path. That is my second path is what? This is what is my x0, x1, x2, x2, x3, x4 and x5, right? And this is what is my straight line path, students. Yes. And now this is what is my particular, that is x0, x1, x3, x4 and xy, right? Yes, this is x0, x1, x3, x4, xy. Just a minute. Okay, so now my third one is, okay, so my third one is stating that x0, x1, x3 and xy. So it is direct. I'll just make it things well. So this is x0, I have a gain of 1, so branch gain of 1, and here it is my x1. So this is x0, x1, and from here it is going to x3, like this, and here it is ending xy. So I need to write whatever for this particular, right? X naught, that is here it is T13 students, yes, this one, right? It is T13, and one more here it is T35, and these are the branch gains that come into existence over here, right? Yes. I have only 4 forward path students, please to understand. Okay, so this is my x5, and here for my x3 have T33, right? Yes, I guess I haven't mentioned that, but I'll mention it over here. This is what is my x0, x3, x4, xy, right? Which one? Here x0, x3, x4 and x5, right? Yes. Yes, okay, yes. So now here what you can see, so here there is a loop, so please to try to write this in the what I can say here round mark, fine, yes, round mark. Loops are always written like this, right? Yes. And now here my last one, so my last what I can say the forward path is that, so that is your x0, x1, x2, x3 and xy. So let me draw that also without fail for you. So it is your x naught having a gain of 1, and this is x1, and it is x2, and here is what I can say my x2, and for this you are having a branch gain of t12, and it is x1, x2, and once again what is telling? Is telling your x not x1, x2, x3 and xy, right? Yes, x3 and xy. This is x2 is having a what I can say my branch gain of t 2 3, and you have x3. So your x3 will come like this. So here your x3 will be like this. So this is what I can say. Here yeah, just a minute. X0, x0, x1, x2, your x3. So your x3 what happens? It will come like this. Right, your x3 will come like this and it will come to xy like this, right? So that is why directly you are supposed to write x3 and xy. Just a minute students, I will rewrite this again. So sorry for the distraction. Okay. Here it comes to be this particular and this particular, that is T33, and here you don't enter any x4, you directly come to xy. So this is what is my x5 having T35, right? Yes, T35, and here is what is my x5. These are all my 4 what I can say the things, right? 4 forward path. 4 forward path. My very first forward path is that is your x0, x1, x2, x3, x4, xy. My second forward path is what I can say my x0, x1, x3, x4, xy, and my third forward path is x0, x3, x4, xy, and my fourth forward path is x0, x1, x2, x3 and xy. This is all according to the this particular diagram. According to which particular diagram? From this particular diagram only I have copied the forward paths, right? Okay, I told you that I'll use this particular diagram and we are going to work for few of the terminologies, and that is what is this one also, right? Forward path. We had define the 4 forward paths by looking at this diagram only, and I have written those 4 forward paths over here. Fine? Yes. Okay, now what is supposed to do after this forward path? So forward path, I guess you understood, right? Like this only you are going to find out your forward paths in the given diagram, right? Now next, what is my feedback loop? So my feedback loop is, we have already learned with respect to feedback loop and the very first thing. So what is that? Is that it is a, what I can say, a path which originates from particular node. A path which originates from particular node and ends at the same node, and they'll travel through one or more nodes, but they don't, what I can say, trace the node twice. That is what I call it as feedback loop, right? What is my feedback loop is that, so it will start at the same node. That means it will originate from that particular node, and it will, what I can say, terminate at the same node, and it will pass through at least one or more nodes, but it does not trace that node again, right? If it is passing through any node, what I can say, if it is passing through node called x3, it doesn't trace again x3 back. So that is what is I call it as my feedback loop. So if I consider with respect to the diagram, feedback loop, in that diagram only we are going to estimate the feedback loop. Fine. I told you by using that diagram only we learn many things, right? Yeah, just a minute. Okay. So now coming on to my feedback loop in this diagram, you can see that, so see, this is my x2, x3. What is my this particular? See, just a minute, students. I am so sorry for the distraction. Okay, yeah. So it is x2, x3, x4 and x2. Right? Let me write that x2, x3, x4 and x2. So it is starting from x2 and it is coming to x3 and it is coming like this and it's coming back and it is going to x4 again, and from x4 it is coming back to x2, right? That is what is the particular, right? Let me draw that without fail. Fine. Now let's do that. Let me, what I can say, the come back to the this one. Which one? This one. Yes. Okay. So if I draw the feedback loop, I just showed you the feedback loop, right? I guess you got it right. Yes. So it is starting from x2. Please to see my x2 is having T23, T23, and it is x3, and what happens is that it will go like this and it will go like this, students, and it will come back to here like this, and then once again it is going to x4. That is minute, give me a minute, students. Yes, and it is once again coming to x4, and from x4 it comes back to x2. So this is what is, I can say, my feedback loop. Why feedback loop? Because it is starting from the same node, right? It is starting from the particular node. What node? That node is what is my x2. It is starting from x2 and it is terminating at the same node, because from x2 it is coming to x3, from x3 it is going to here, and once again it comes to x4 and it comes back to x2. I am showcasing using my pen, you can understand, right? Yes, this is what I am trying to tell you. So, and it will pass through at least one or more nodes, right? It will pass through at least one or more node, right? It is passing through at least one or more node. It's passing through x3 and x4, but it is not tracing that node twice. Is it tracing the node twice? No. It is coming back to x2 over here. See here, from x2 it passes to x3, and from x3 it is making a transition like this, and after it makes a, what I can say, just a minute, I'm so sorry. Yes, after making a transition like this, it will once again come back to x4. From x4 it once again goes back to x2. In this diagram you can see that it is not, it is passing through x3 and x4, but it is not tracing that x3 and x4 once again. Can you see? It is not, what I can say, tracing x3 and x4 once again, right? That is why I call it as what? I call it as my feedback loop, right? What is feedback loop? My feedback loop is nothing. It will emerge from a particular node, and it will what I can say terminate from the same node. It will pass through what I can say the at least to one or two nodes, but it will not trace that nodes again, right? Yes. And now next one is that self loop. Self loop is what? A feedback loop consisting of only one node is called as my self loop, right? Yes. So that is my T. This X3 is my self loop here. This is what is my self loop, because this feedback loop is consisting of only one node, right? The feedback loop consisting of only one node is called as self loop. That is my X3 is what? My X3 is what? My self loop, right? Yes, because it's consisting of only one node. That is what is my self loop over here in this feedback loop, right? And what is my path gain? So that is the products of branch gain while going through a forward path, right? When you go through a forward path like this, what is the product of branch gains that you see is what is my what I can say the path gain, right? So let me write it over here, my path gain. So my path gain here is, it is what I can say the 1 into T12, that is what I can say T23, T34 and T45. It is only forward path, not feedback path. It is only forward path. Please to understand, it's only forward path. That is product of branch gains that you see while going through the forward path. It is what? It is T1, 2 and 2. What I can say the T1 and 2, T1 2 into T2 3, that is what I can say into T3 4 into T4 5. This whole line, see, this whole line is a forward path, and so for this forward path, whatever the what I can say the product of branch gains that you see when you pass through a forward path, it is what is called as my path gain, and this is what is my path gain, right? Yes. And now let me come to dummy node. So what is my dummy node? So my dummy node is stating that I have to write a separate diagram for this. Till now we have used the same diagram, right? Yes, I'll rebrush it all of this again. So please do wait. So let me write my dummy node. Okay. So for my dummy node, if there is any incoming and outgoing branches existing at first and last node representing input and output variables, so these can be called as a source node and a sink node. So my source node is what? Node is having only outgoing branches, and what I can say my sink node is node which is having only incoming branches, right? So source and sink nodes, or I can say it is a chain node directly, because it is consisting of both incoming and outgoing branches, right? Yes. So this is what is my okay, and here is what is my this is consisting of both incoming and outgoing branches, right? It is consisting of both incoming and outgoing branches, both at the first and last node in this diagram, right? You can see. So it is consisting of this incoming branches as well as outgoing branches. So this branch is outgoing, and this also outgoing branches, incoming and outgoing branches for what I can say the representing both at the first and last node, and are representing input and output variables. So they are called as source and sink nodes. So for this case, so you can have separate input and output nodes by adding a branch gain of 1. So see, for here you can have a separate input and output nodes, what I can say, by adding a branch gain of 1. So here you add a branch gain of 1. So here you add a branch gain of 1. So which is called as my what? So which is called as my dummy node, right? So what do you mean by dummy node? So you have a what I can say the incoming and outgoing branches at the what I can say, both are the first and the last node, they are representing input and output variable. So for that condition you call it as dummy node. But what is that going to happen is that, so when you for this condition you have to add what I can say separate input and output nodes by adding the branches with gain 1. So therefore that is what is I call as dummy node, right? Yes. And if I come to what I can say, so this one. So what I can say, if I come to my non-touching loop, so non-touching loop is that easier. So that is if there is no node common between two or more loops, so it is what I call it as non-touching. That is in the sense, for example, when you encounter what I can say loops. So when you encounter a loop for two or more loops, there should not be a same common node, right? Yes, for two or more nodes, there should not be x3 that is common to you. That is what is called as what I can say my non-touching loop. Right, I'll write one this particular thing. So just a minute, I'm going to write the diagram over here. So say I'll write three non-touching loop diagram. Okay, so here is what is my x1 and x2. Here is what is my x1 and x2, which is going to be L1. And here is what is my, what I can say, the this one, that is x3 and x4. x3 and x4, that is L2. Okay, and this is what is my, what I can say, my x5 and x6. These are all three non-touching loops, wherein you can see that for this loop any of the node is not at all repeating, right? So you can see that the nodes are not for x1 and x2. You don't have any, you have nodes called as x1 and x2. Let me consider you have a, what I can say, nodes called as x1 and x2. And if you come to this particular loop L2, so you can see that there is no x1 and x2 that's been getting repeated. You have a node called as x3 and x4. And for loop 3 you can see that you have a node called as x5 and x6, wherein the other nodes, that is x3, x4 or x1 and x2 is not repeating for you. So that is why I say that it's not touching loop. That is what I guess you understand, right? For any loop there should not be, what I can say, that is the there should not be any nodes that has been repeated, right? There should not be any nodes that is repeated. The nodes should be a newer node. Here there are two new nodes, that is x3 and x4. Here you don't find any x1 or x2 over here in the loop L2. And here in the loop L3 also it is a new node, that is xy and x6, and you don't find any x3, x4 or x1, x2. That's the older nodes. That is why I say it is non-touching loop, right? So now coming on to what I can say my this one. Okay. So coming on to the other one. So that is your loop gain. So what is your loop gain? So what is your loop gain is what I can say, the last one. This is what is the last terminology. What is a loop gain? A loop gain is product of all the gain of the branches that is forming a loop, is what is my call it as my loop gain. That is, these are all loop gain, that is L1, L2 and L3, right? This is all my loop gain. That is what? A product of all the gains of the branches forming a loop. That is what, you listen to it properly. The product of all the gain of the branches, so that branches which is forming a loop, so the product of those branches you can call it as my loop gain. That is for your L1, what happens is that for your L1 what I can say, that is your what I can say, I have to write a separate diagram for it. So just wait a second, I'm so sorry. Okay, yes. So let me draw one diagram and explain it to you clearly. So this diagram is more than sufficient. So we are going to learn about this in detail in all the what I can say my problems, because in problems only you get to know things in a clear manner, right? Yes. And this problems, what I can say, I will try to what I can say, do it on a pen and paper and explain it to you clear manner, or let me try to make use of an other methodology, right? But I want you all to understand it in a clear manner, right? Yes, this is x3. and this is x4. Yeah. And here is telling that, so what is telling, we are going to find out what I can say, the loop L1. So the loop gain L1 we are going to find it. What is loop gain L1? So that is the gain G2. Just a minute, I'm so sorry, I'll erase this. Gain G2 into minus H1, right? What is L1? So my L1 is equal to, what I can say, my H is the feedback loop, my G is the forward path, right? Yes, so that is what is my G2, that is forward path G, forward again G2 into, that is minus H1, that is feedback, right? Yes, this is what is my, what I can say, the L1, or I can write it as, what I can say, just a minute, it is minus G2 H1, right? Yes, so this is what is the all the terminologies, right? I guess you understood the loop gain. That is the product of all the branches which is forming a loop, which I call it as my loop gain, and I can directly write the loop gain L1 as, that is equal to, so that is what I can say, my G2 into H1. This is forward into feedback, so I get it as minus G2 H1. So now let me come back to all the, what I can say, explanation thing, brushing it again. So this is what is my diagram, and from this diagram we have learned many things. So this is super important, I already told you, because it is nothing but a diagram itself, right? In a diagram all of this are present, and you should have the capability to identify all this and then start solving the problem. That is why this is super important for you. I guess you understand, right? Yesterday's, today's and tomorrow's is also super important. If you know all the three things, then you can easily do it. So see here, it is source, sink and chain. So what is your source, sink and chain? Your source node is, it is a node consisting of only outgoing branches. So my X node is consisting of only outgoing branches. There is no incoming branches here. Right? Is anything incoming to X node? No. This is outgoing. So that is why it is source node. And what is my sink node? A node which is consisting of only incoming branches. See, that is what is my sink node and XY. For my XY, all the things are coming to XY. So it is going from X0 and it is coming to X5. So that's why it is sink node. And chain node is what? Node it's consisting of both incoming and outgoing, which is what I call it as my chain node, right? And what is my forward path? So what is my forward path is that, that is the branch gains that you pass from the input to the output node. So the path from input node, this is input node and this is output node, and path from the input node to the output node, that is what is I call it as my forward path, right? My first forward path is the straight line, that is x0, x1, x2, x3, x4, xy, and my path 2 is x0, x1, what I can say, just a minute students, I'm so sorry, x0, x1, yeah, my second one is x0, x1, x3, x4, xy. See, this is x0, this is x1, from x1 it goes to x3, and from x3 it comes back to x4 and xy, right? And my next one is what? My next one is x0, x3, x4, xy. So this is x0, this is what I can say, just a minute students, I'm so sorry. It is x0, x1, x3 and xy. I'm really sorry for the mistake over here. X0, x1, I'm so sorry, just a minute. Okay, so this is x0, x1, x0, x1, and from x1 it goes to x3, and from here it once again goes to xy. This is what is my forward path number 3, and my forward path number 4 is x0, x1, x2, x3, xy. x0, x1, x2, and once again it goes to x3 and xy. So this is what is my forward path, right? And then this is forward paths are derived by this diagram itself. So by using this diagram only, we have found out that there are 4 forward paths, and that we have already identified, and we have written it over here, right? And my next one is what is my feedback loop. So what is my feedback loop? My feedback loop is that it is what I can say, a path that is originating from one loop, it will terminate from the other loop, and it will, what I can say, go through the one or the other node, travel through one or the other node, but it will not across that node repeatedly, right? I can say it will not trace that node repeatedly. That is what I call it as feedback loop. See here, it from x2 it is going to x3, from x3 it is coming once again back to x4, and from x4 it goes to x2. Here it is what I can say, it is originating from this particular node, and from this particular node it's terminating from the same node, and it travels through one or more node, but it does not trace any nodes repeatedly, right? It does not trace any node twice. Is it tracing any node twice? No. See here, x2, x3, x4, x4 and x2. It is what I can say, tracing the node only once. It is not tracing twice. Is it tracing x3 twice? No, it is tracing x3 only once. Is it tracing x4 twice? No, it is tracing x4 only once. And is it tracing x2? It will dominate from the same node, so because it has to come back to x2. So this is what is my feedback loop, right? I guess you understood things in a better manner. So here it should travel through, it should, what it should do, it should, what I can say, originate from the particular node, that is x2. It should terminate at the same node, that is x2. It should travel through one or more node, that is x3 and x4, and it should not trace these x3 and x4, what I can say, twice, right? Yes. And what is my self loop? Self loop is the feedback loop which is consisting of only one loop. So this feedback loop, it is consisting of only one loop. So that is what is I call it as self loop, and x3 is my self loop. And what is my path gain? I have written the path gain over here, that is the product of branch gains. So while going through a forward path. So I am so sorry students. Yes, yes. So this is the product of branch gain. So these are all 1, T12, T23, T34 and T45. I am showing the arrow mark. So see, please follow this black one arrow mark. It is 1, T12, T23, T34 and T45. So these are all my branch gains, and the product of all this when it is traveling through this particular forward path is what I call it as my path gain, and it is 1 into T1 1 into T1 2 into T2 3 into T3 4 into T4 5, right? And what is my dummy node? I say that my dummy node as if there is any what I can say, incoming and outgoing branches, that is both are the input, and that is the first and the last node, and representing input and output variables. These are called it as my source node and sink node. That is, there are incoming and outgoing branches which is both at the first node and the last node, and they're representing input and output variables. So I can tell that as my, what I can say, source and sink nodes. In such a case, a separate input and output nodes can be created. So you can create a separate input and output nodes by adding up branches with gain 1. So that is why I call it as my dummy nodes, right? In the sense, so just a minute. So this x1 and x2 are what I can say the input and output nodes, and you have both incoming and outgoing nodes at x1 and x2. They represent input and output variables. But what is that going to happen is, so the x1 and x2 are input and output variables, but these two are not input and output nodes. So therefore at that point of time you generate a node by having a branch gain of 1. So that is why what I can say, I can tell it as my dummy node, right? And what is non-touching loop? If there is no node common between the two or more loops. So for example, these are loops, and for this loop there is no one or more, what I can say, node common between these two loops. So here for L1 it is x1 and x2, and for L2 it is x3 and x4. For L2 is there is x1 and x2 present? No. There is no common x1 and x2 over here. For L3 it is xy and x6. For xy and x6, is there is any common nodes, that is x3, x4 and x1, x2? No. So that is why I call it as my non-touching loop. That is, there should not be any, what I can say, node that is common between two or more loops. Any node in the sense, if there is a node called as L1 having L2 having x3 and x1, for that there should not be x1 and x2 in common, right? Yes. Common between, any node common between two or more loops, which is what I call it as my, what I can say, that is your non-touching loop, right? You can take an other example over here. Just a minute. Yeah, it is for this one. Yeah. Other example over here wherein I have a line. I'll erase it, just a minute. So I'll remove this folder. I can take another example. Yes, wherein you can see here it is x1 and x3, right? This is L1. This is my x1 and x3. So here for my x1 and x3, what I can say, this is what is my non-touching loop, and here also it is x1 and x4. This is x1 and x4. Just a minute, I'm so sorry. X1 and x4. So these are all my, what I can say, the non-touching loop, because this one loop is L1, that is x1 L1, that is what is my x1 and x3, wherein for that x1 and x3 there is no other nodes in common like x1 and x4. So that is why this is what is my very first, what I can say, the non-touching loop. And here for x1 and x4 you can see that there is no, what I can say, for L2. If you consider your L2 over here, what I can say, if you consider a L2 over here, so L2 is what, that is x1 and x4, wherein there is no other node in common. For this x1 and x3, this node L1, see here for this node L1, so you can see that this is only x1 and x3. There is no other node called as x1 and x4 in common, right? And for this node L2, there is only x1 and x4, wherein your x1 and x3 is not in common, right? This x1 is different, right? This is, you can take it as x2 students, because there should be no two nodes repeating. That is why I guess it's a mistake in the textbook. So I'm taking the diagram from the textbook. So it is x2 and x3. So this x2 and x3, there is no x1 and x4. So here for x1 and x4, there is no x2 and x3 in common. This x1 and x4 is one loop L2, one loop gain, that is L2, wherein there is no, what I can say, my x2 and x3 in common. That is why it is non-touching loop, right? Yes. And now here, what is my loop gain? So my loop gain is star. So what is my loop gain? So what is my loop gain is star. So therefore the product of all the gain of the branches, that is forming a loop. So that is product of all the gain of the branches. So that is what I can say. There are some branches and the gain of this particular branch, that is forming a loop, is called as my, what I can say, the loop gain. And that is L1, which is equal to this gain, that is branch gain, into, what I can say, what is my, just a minute, what is my, it is my branch gain into this minus h1. H1 is my feedback. So this is minus g to h1. I guess you got it right. It is the product of all the branch gain that is forming a loop, right? That is forming a loop. So the branches branch gain. The gain of the branch is forming a loop, which is what is called as my, what I can say, the loop gain. And this loop gain for L1 is given by this branch gain g2 into this minus h1, or I can say it as minus g2 into h1. So this is what is for today's lecture. Please do try to like, share and subscribe, and please do understand this concept clearly so that it would be helpful for solving this particular problem. Please do try to understand this without fail, and thank you.